Hey guys, welcome to Fun and Studies. I'm Aprame and today I have come up with you for the class 9 chapter 8 motion. Let's start. About motion. Motion is a common phenomenon observed in our daily life. A moving bus, a running dog show motion, while the rock lying on the road does not show motion and we say that it is at rest. So here, the first line. It means a moving bus and a running dog. They move from one place to another and they show motion, while the rock which is lying on the road, it does not show any motion because it does not move from one place to another. Change in weather, day and night, sunset and sunrise are all the consequences of the motion of the earth. But without mentioning the observer, there is no point in mentioning these terms. Change in weather, day and night, sunset and sunrise. So these are the changes which all occur due to the moving of the earth. But without mentioning who is gonna view this, there is no point in mentioning about these terms. So by the end of this chapter, we will be able to understand what motion is and how the physical quantities like velocity and acceleration help us describe it. So in this chapter, we will learn about all this: state of a body, motion along straight line or rectilinear motion, speed and velocity, acceleration and retardation, graphical representation of motion, derivation of equations of motion by graphical method, and sign convention, uniform circular motion, and we will do a quick recap in the ending. So here I'm gonna divide this into three parts. So in the first video, we will complete the first three parts. So first, state of a body, reference point. What is the reference point? It is a location or position of an object and is described by specifying the reference point. So an object position is described by specifying the reference point or the point from which we see as the starting point, and the location of the object is described. The point from which location is observed and measured is called as the reference point. The reference point is also called as the origin. For example, if we say that school is situated 5 kilometers west of a temple, we have specified the position of the school with respect to the temple. So here, temple is the reference point and school is the point which is getting described from the reference point as 5 kilometers west from a temple. A system of geometric axes in relation to which measurements of size, position, or motion can be made is called frame of reference. Next, rest. If an object does not change its position with respect to a fixed point taken as a reference point, and its surrounding with the passage of time, it is said to be at rest. So let's take a everyday example. We sleep. So it, in other words, our body takes rest. So what does rest mean here? Our body does not move or does not do any work and regains its energy. So here the body does not move. Object does not change its position. And body does not move with respect to what? The mattress or the bed which sleep on, with respect to a fixed point taken as a reference point. And surroundings, whoever is looking at us or checking how much time we are gonna sleep. And with the passage of time, so we sleep like 6 to 8 hours a day, and this passage of time, our body does the least amount of work and regains its energy back. For example, a book placed on a table remains on the body if not disturbed by anybody. Therefore, its position is not changing with respect to the table with the passage of time, and we can say that the book is at rest with respect to the table. So here the reference point is the table and the object is the book. Next, motion. An object is said to be in motion if it changes its position with respect to a reference point in its surroundings with the passage of time. So, for example, we will take the person in this picture. He is doing skating and he does skating. Let's take the time 5 minutes, and he is doing skating non-stop with for this 5 minutes, and and we will take the starting point as point A and the ending point as point B. So this object or this person changes his position from point A to point B, and in the passage of time 5 minutes. Understood? This is motion. For example, a moving car changes its position with respect to its surroundings with the passage of time. Interrelation between rest and motion. So both of these terms are interrelated, and we'll see how. An object may appear to be moving for one person and stationary for another person. Rest and motion are not significant without a viewer. Nothing is at absolute rest or in absolute motion. So for one person, an object may look that it is moving, and for other person, it may look it is not moving. Rest and motion are not significant without a viewer. So if one viewer is there, we find that the object is at rest, and another viewer, it is at motion. So without the viewer, whether it be in rest, whether it be in motion, it is not at all significant. Nothing is at absolute rest or in absolute motion. So for example, let's take me. So here I am sitting here in a chair and the laptop is front of me and I'm recording this video, and I'm respect I'm uh, I'm at rest respect to the viewer, which are you, and the laptop which I'm recording the video in. But am I not in rest? Am I in rest with respect to others who are outside the earth? Because I live on the earth, and the earth is always moving in motion. So with respect to the laptop, I am in rest, and with respect to a viewer, for example, let's say astronaut who is outer in the space, I am in motion. So let's take another example. For example, a robber enters into a moving train, brings out his knife and says, "Don't move, stand still." The passengers stand still. The passengers are at rest with respect to the robber but are moving with respect to the tracks. Hence, we can conclude that the state of motion and rest are in a combined property of the object under consideration and the observer. So here it is a robbery in a train. So now let us see the types of motion. There are various types of motion, as an object may move in various ways. An object moving in a straight line is said to have rectilinear motion. If I roll a ball over the floor and it moves in a straight line, then the ball is having rectilinear motion. A body moving around a curved path and is said to have along a curved path is said to have curvilinear motion. And if I fix a track now, and if you viewers are kids like me, then I might know that you know Hot Wheels. So Hot Wheels cars, and if we move it around the track which is in circular, the Hot Wheels car is said to have curvilinear motion. An object moving around a fixed point has rotatory motion. For example, let's take the example of the wall clock. Here, the hands of the clock are moving, but with respect to the starting point, which is in the center of the clock, the points are just the hands are just spinning around this point, and this is known as rotatory motion. The pendulum of a clock moves to and fro above the main position and is said to have oscillatory motion. So this sentence tells us the to and fro motion is nothing but oscillatory motion. The motion of a sitar string when plucked exhibits vibratory motion. A sitar, a guitar, and even take a rubber band, stretch it really hard, then ask your friend to just flick it once, and then the vibration occurs, and you might even hear a sound. And this sound we'll discuss in the later upcoming chapters. An object can possess more than one kind of motion. If an object possesses two or more types of motion at the same time, then such motion is called multiple motion. So let's take an example. This truck here is moving on the road, and the truck is moving around along a straight line here. So let me just annotate. So it is moving around the straight line here, and it is moving in a straight line and is having rectilinear motion. Rectilinear motion. And here, let's look at the wheels of the truck. So, with respect to the center of the wheel, they are rotating. So, they even have rotatory motion. So, this truck has more than one kind of motion, which is rectilinear and rotatory motion. So, this is a example of mixed motion or multiple motion. So, the branch of physics which deals with the study of the motion and the response to the force. So, not so sometimes when we apply force, the object does not always go into motion. It sometimes does not change its position, but we are applying force there. For example, we push a wall, but the wall does not move, but we are applying some force on it. So the branch of physics which deals with this is called mechanics. Distance and displacement. Distance. It is the total path length covered by an object during the entire journey without taking into consideration its direction. It is a scalar quantity and is always positive for an object in motion. So, distance, this is a familiar term, and displacement. When a body moves from one position to another, the shortest distance between the initial and final position is said to be the magnitude of displacement. And it is directed from initial to final position. Its vector quantity, it may be positive, negative, or zero. So here let us see the difference between distance and displacement. So distance, it is the total length. Displacement, shortest length. Distance, it is always positive because it moves from one point to another. But displacement can be negative, positive, or zero, because if the if we go from point A to point B and point B to point A, the initial and final position are A itself. So here if we so here we don't consider how much ever it traveled, but in distance we check how much it travels, and in displacement we just look at the initial and final position, and here both of the positions are a. So so the displacement moved, or magnitude of displacement, is 0. Relation between distance and displacement: when a body travels along a straight line in the same direction, then the distance it travels is equal to its displacement. So sometimes distance and displacement are same. Let's take the truck example. Let's go to the previous pages. So here, distance point A to point B. Displacement, so the point A is initial point and point B is the final point. So here the distance is A to B and displacement is also from A to B. So both can be same. So there are various situations when a body has traveled a certain distance and it has zero displacement. So let's take the example. Again, let's go to the truck example. So here, point A, B. So here, let us take the truck moves from point A to point B and returns back from point B to point A. So here the initial and final point is point A. So displacement is 0. Is 0. But distance covered is A to B and B to A. So for example, let's take this distance between point A and B is 10 meters. So displacement is 0 meters and distance covered is 20 meters. So displacement and distance. But the truck has covered the same length, but displacement is 0 and distance is 20. So let's take another example. If we take a round trip and come back to the starting point, then although we have traveled some distance, our net displacement will be 0 because the initial and final position are same. So it is the same example. So we'll take another relation. So this is the similarities and this is the differences. So here distance and displacement. Distance, it is the actual length or length of actual path covered irrespective of direction of motion. Displacement is shortest distance between initial and final points in a given direction, because it is a vector quantity and this is a scalar quantity. Because it is scalar, it is irrespective of direction of motion. It is vector, so it is respective of given direction. Distance covered can never be negative. It is always positive or 0. Displacement may be positive, negative, or 0. Distance between two given points may be same or different for different path chosen. Displacement between two given points is always the same. So this last one, let's go to another site and I'll explain the last point in detail. I'll just come back. So here this is the questions actually. So let's see here. So here point A is there, point B is there. So what is displacement? Point A to point B. But what is distance? We can go however we wish to. We can go in the displacement way, or we can take any other route. So distance is always equal or greater than displacement. So I'll just clear this. 1 minute. So here we completed this last point also, the explanation. So next, speed. So speed you might already know, but just let us check in the brief. The speed of a body is defined as the distance traveled by it per unit time, or that is speed is equal to distance divided by time. If a body travels a distance s, so the symbol of distance is s, and symbol of time is t. The symbol of speed is v. Travels a distance s in time t, then its speed v is given by v is equal to s divided by t. So it is a scalar quantity because distance is a scalar quantity. And the SI unit of distance is meters and that of time is second. Therefore, SI unit of speed is meter per second, written as this meter per second or ms minus 1. And other units also include centimeter per second and kilometer per hour. Kilometer per hour you might check in the automobiles. Most of the times you will just look at this symbol in the automobiles. Now let us look at types of speed. So here there are three types of speed: average speed, uniform and non-uniform speed. So average speed, it is defined as the total distance traveled by a body divided by the total time taken to cover this distance. So it is just like the mean. In the mathematical way, it is just the mean. And it is a scalar quantity. Average speed is equal to total distance taken by the body divided by the total time taken. If a body travels a distance s in time t, then its average speed v is equal to s divided by t. The SI unit of average speed is meter per second. It can also be expressed in kilometer per hour or centimeter per second. So this is about average speed, uniform speed or constant speed. If an object covers equal distances in equal intervals of time. So in uniform, both are constant, equal distance and equal intervals of time. So this time, if you might think it should be larger than, for example, take 10 minutes and we move 100 meters and again 10 minutes, again 100 meters. No, it can be however small it may be. It can even be like 1 second or even milliseconds or nanoseconds. To look at the constant speed. However small the time intervals may be, then its speed is said to be uniform. For example, a car running at a constant speed of 20 meters per minute will cover equal distances of 20 meters in every minute. So here what is the unit? Meter per minute. So I'll just write it here, meter per minute. So now I'll clear it. Now let us see non-uniform speed. If an object covers unequal distances in equal intervals of time. So here we can do the either other way also, like equal distances in unequal intervals of time, or uh, unequal distances in equal intervals of time. So because we cannot always keep measuring the time, however how much we are covering the distance and then the different time and the again distance and different time, so it will be harder. So here I wrote it as equal intervals of time. So unequal distances in equal intervals of time, no matter how small the time intervals may be, then its speed is said to be non-uniform speed. For example, the motion of a car on a crowded road and the motion of a freely falling body. Let's look at velocity. Velocity of a body is the distance traveled by it per unit time in a particular direction. So what is this? So what is the difference between velocity and speed? So here uh it is a vector quantity and speed is a scalar quantity, and speed does not care about the direction. Displacement cares about direction, and velocity is nothing but displacement by time. So it is equal to distance traveled in a given direction, or in simple words, displacement by time taken. Velocity has magnitude as well as direction. It is a vector quantity. Its units is same as the unit of speed, which is meter per second, centimeter per second, kilometer per hour, etc., etc. Velocity of a body can be changed by changing its speed, direction of motion, or both. So velocity also has the same kind: average velocity, uniform velocity, and variable velocity, just as the speed has. So average velocity, it is defined as the total displacement of a body divided by the total time taken to cover the displacement. If uh, two are the positions of an object at times t1 and t2, if x 1 and x2 are the positions at times t1 and t2, then the average velocity from t1 to t2. So t1 is the initial time, t2 is the final time, and it is x2 is the final velocity, x1 is the initial velocity, and it is given as x2 minus x1 by t2 minus t1, or triangle symbol x divided by triangle symbol t. When the velocity of of a body moving in a straight line is changing continuously at uniform rate, then the average velocity is given by a metric mean of initial and final velocity, that is u plus v divided by 2. So u is initial velocity, v is final velocity. Here uniform velocity is same as uniform speed, and variable velocity is non-uniform speed. And it let us look at variable velocity. A body is said to have variable velocity if it has non-uniform speed, or its direction of motion keeps on changing, or both its speed and direction keeps changing with time. An object traveling with non-uniform velocity is said to have non-uniform motion. Next is instantaneous velocity and speed. The average velocity and the average speed of an object tell us how fast the object is moving in a given interval, but it does not give how fast the object is moving at a particular instant. For example, the average of speed is 10 100 meters per 10 seconds. So that is the average. And I want how much distance it covered in the 7th second. Does the average velocity tell us? Average speed tell us? No. So now we look at another one, which is instantaneous velocity and speed. For example, a man drives from his home to office. His average speed can be found out by dividing the total distance taken by him by the total time taken. But during his journey, he increases or decreases the speed of the car in which he is traveling. That is, speed of the car is not same at different instants. So if speed is not same, so if we need a particular speed which is at this particular instant, we need instantaneous velocity and speed. To this we have instantaneous speed and velocity. Instantaneous velocity, it is the velocity of an object at a particular instant or at a particular point of its path. So here we can calculate it by the particular point of time or particular point of length, and it is called as the instantaneous velocity. Instantaneous velocity of the object can be defined as the average velocity of an over an infinitesimally small time interval. So here, if we need to calculate, we take the average velocity divided by a really small interval of time. So here infinitesimally means the time interval should be really small, that the quotient should be near to infinite. Instantaneous speed. The speed at any instant of time is called the instantaneous speed. Generally, the instantaneous speed is simply called as the speed. Speed and average speed. So these are some important points about instantaneous speed and velocity. If an object moves along a straight line without changing its direction, then the magnitude of average velocity is equal to average speed. If the body is moving with constant velocity, then the average velocity and instantaneous velocity are equal. When the body moves with velocity v1 and v2 for equal interval of time t, then its average velocity is given by VAV. VAV means V average, or velocity average or speed average is equal to v1 plus v2 by 2, because 1 plus 2, so there are two quantities, divided by 2 for average. So it is just as the arithmetic mean. When the body moves at equal distances with velocities v1 and v2, its average velocity is given by VAV is equal to 2v1 v2 by v1 plus v2. So this is another really important point, and I suggest you to note it down, because here today, from today this video, I'm gonna give few questions, and to solve the questions you might need these formulas. The odometer fitted in automobiles measures the distance traveled by it in kilometer, whereas speedometer shows the instantaneous speed of the automobile. So to identify it, I have brought the pictures. This is odometer. It has the reading of how many kilometers it has already traveled. And this is speedometer. It gives the speed at a particular instant. And here in this picture, it is showing as 0. And in a vehicle, it is usually beside each other, and here odometer, this thing is there, and speedometer also it is there, but here it gives the total, it gives us the measure distance traveled, measure of distance traveled, and which is here in this picture 6381 kilometers, and here it gives the speed at a particular instant. So we are near to the ending of the video, and I would like to end this video with few questions. So this is all there in the video, and I will ask you to try these three questions, and in the upcoming video I will solve these three questions first and then continue with the upcoming lesson, which is after instantaneous velocity and speed, we have um, acceleration and retardation. So after solving these questions, then we will continue with this acceleration and retardation. So thank you for watching this video and bye.